let's take a look at some Altum sensor data. I've got two options here. I can either download sample data, so that would be the raw TIFF files from the flight if I wanted to process that in a photogrammetry software. I could also download the processed GeoTIFF and pull that into something like QGIS for analysis. The quickest way, though, is to do the online data viewer, so that's what I'll look at here. And it will pull up a Hemp dataset first. We've got all the flight information here on this first information tab. And then the second tab will show us the data layers available. So you can navigate through each one. RGB composite is first, and then it is CIR composite. So instead of the red, green, and blue bands, we're looking at near infrared, red, and green. And we can see variations in plant vigor here. Then I can look at the weeds layer as well. This one will show the crop as a mostly orange color, and then any variation in color could be indicative of weeds. So in this case, the yellow we're seeing here, if I zoom in, that's actually indicative of just lower plant vigor. So the hemp plants that are underperforming. So that's something that we could already see in the CIR composite. If I navigate to another part of the field here, I can see that there are some red spots throughout. So that is something that we're not seeing variation there in the other layers. So I'm not seeing anything in RGB composite or really in CIR either. But then we see the variation in the weeds layer. So that would be indicative of it does look like weeds. So we did ground truth that area, and indeed it was a grassy weed that looks very similar to the hemp plant. So it is one where it was useful to utilize the multispectral bands for differentiation there. Next, there's NDVI, and this one is, since it's a mid-summer, mid-season flight, we're not going to see much variation here since NDVI is correlated with biomass. Where we are going to see variation is NDRE. That's more correlated with chlorophyll content. So any kind of stress later season will be more visible due to dropping chlorophyll levels. And so here we can see some striping throughout the data set, areas where these kind of mid value yellow lines show up. And this seems indicative of a incomplete fertilizer application. So areas where they didn't completely overlap when they went through with the sprayer, therefore areas that didn't get applied fertilizer to. We can also see another way to view NDRE is NDRE plants. That's one I like to look at personally, and then I put the RGB composite in the background. So with this, I'm just eliminating the soil pixels, and I'm just looking at vegetation here, so it makes it a little bit easier. And here I can start to see a lot more clearly how much better this kind of looping area is doing. That's actually because after seeding the field initially, there was extra seed left over, so they just drove through and applied the excess so as not to waste it. What that resulted in actually is some really good growth in this otherwise problematic area of the field. So that it could be some good insight for next season to do a higher seeding density in that area to get more uniformity throughout the field. And then the last layer I'll look at here is thermal. And I'm able to look at that since this is an Altum data set. And the hottest areas here are showing up as yellow. Those correlate with areas where soil is peeking through and heating up throughout the day. Whereas the majority of the area where there is crop coverage, that is pretty cool. And that's because the crop canopy is transpiring and keeping the plants pretty cool. We can notice here if we toggle between NDRE and thermal that the lowest NDRE values, or areas where soil is peeking through the most, are the hottest. So that makes sense. Besides that, we're not seeing any areas where there's really water stress. So that's the hemp sample data set we've got. In addition, we've got other data sets, both from Red Edge and dual camera data, so feel free to navigate those yourself as well.